There is a specific category of computer hardware that represents a substantial installed base worldwide that the current versions of Windows cannot run on, and that Linux can run on with performance that is not just adequate, but often excellent. The category is computers from roughly 2010 to 2015, with specifications that include dual-core or early quad-core processors, 4 to 8 gigabytes of RAM, and mechanical or early solid-state drives. These computers, which were reasonable machines when they were new, are now unsupportable on Windows 11 because of the hardware requirements Microsoft has imposed, including the TPM requirement, the specific processor requirements, and the general expectation of substantially more capable hardware than these machines have. For users who own these computers and who do not want to replace them, the Windows option is limited. Windows 10, which is the last version they could run, is no longer receiving security updates as of October 2025. Windows 11 will not install. The specific options have narrowed to running Windows 10 without security updates, which is a serious security risk, or switching to a different operating system. Linux provides a specific option that addresses this situation, with performance characteristics that are often better than the performance the computers had when they were new and running the Windows versions of their time. I want to walk you through what Linux distributions work well on this class of hardware, what the specific performance is, what trade-offs are involved, and why this specific situation exists. Let me start with a specific hardware profile I'm talking about. A typical computer from 2010 to 2015 that is now in the category of hardware that cannot run Windows 11 has specifications that include a processor, such as an Intel Core i3 or i5, from the 2nd through 7th generations, 4 to 8 gigabytes, of RAM, a hard drive that is either a traditional spinning disk or an early solid-state drive of 128 to 256 gigabytes, integrated graphics rather than discrete graphics, and a display that is typically 1366 by 768 or 1920 by 1080. These specifications were mainstream when the computers were new. The computers were adequate for the Windows 7 or Windows 8 or early Windows 10 that they originally ran. They remained functional hardware with no physical defects, capable of basic office productivity and web browsing. On Windows 10, these computers have become slow. The Windows 10 that they are running has received years of updates, and the updates have progressively increased the system resource requirements. The computers that handled Windows 10 adequately when the computers were new now struggle. With Windows 10, because Windows 10 itself has grown to require more resources, boot times are long, application launches are slow, the system feels sluggish in ways that it did not feel when the computer was new. On Linux, the experience is different. A lightweight Linux distribution running on this hardware boots quickly, launches applications responsively, and feels like a new computer. The specific difference is substantial and consistent across various combinations of hardware and Linux distribution. Let me describe the specific Linux distributions that work well on this class of hardware. The first is Linux Mint with the XFCE desktop environment. Linux Mint is one of the most user-friendly Linux distributions, and the XFCE version is specifically designed to be lightweight. The system requirements are modest, the desktop is familiar to Windows users, and the included applications cover all typical needs. Linux Mint XFCE runs very well on hardware with 4 gigabytes of RAM and an older processor. The second is Xubuntu, which is Ubuntu with the XFCE desktop environment. Xubuntu provides the Ubuntu Foundation, including the extensive package, repository, and the long-term support commitments, with a lighter desktop. The specific experience on older hardware is similar to Linux Mint XFCE. The third is Lubuntu, which uses the LXQT desktop environment. LXQT is even lighter than XFCE, which makes Lubuntu suitable for even older hardware with as little as 2 gigabytes of RAM. The trade-off is that LXQT is a slightly less polished experience than XFCE, though it has improved substantially over recent years. The fourth is MX Linux, which is based on Debian and which is specifically designed to run well on a wide range of hardware, including older hardware. MX Linux has been a top-rated distribution on various community rankings for several years, and the specific appeal includes its performance on hardware that struggles with other distributions. The fifth is Peppermint OS, which is designed specifically for older hardware and for users who want a lightweight but functional experience. The specific features include a minimal default set of applications, which keeps resource usage low. The sixth is Anti-X, which is designed for very old hardware. Anti-X can run on computers with less than a gigabyte of RAM, which is more than most other distributions can manage. The trade-off is that Anti-X is less polished than the mainstream distributions and requires more comfort with basic Linux concepts. The seventh is Zorin OS Lite, which is the lightweight variant of Zorin OS. Zorin OS specifically targets users who are migrating from Windows, and the interface is designed to be familiar. The Lite variant is optimized for older hardware. Across these distributions, the specific performance on older hardware is substantially better than Windows performance on the same hardware. The boot times are typically half of what Windows produces. The memory usage is typically a third to a half of what Windows consumes. The application launch times are substantially faster. The overall responsiveness is noticeably better. The specific reasons for the performance difference include several factors. The first is that Linux distributions, especially the lightweight ones, are simply smaller than Windows. The operating system code that is loaded into memory is less, which leaves more memory for applications. The number of background services is less, which leaves more processor time for user activities. The overall resource consumption is lower. The second is that Linux is generally more efficient in its use of hardware resources. The specific kernel optimizations, the specific process scheduling, and the specific memory management all produce better efficiency on the same hardware. The efficiency is particularly noticeable on older hardware that has less headroom to absorb inefficiency. The third is that Linux distributions typically do not include the advertising, tracking, and commercial integrations that Windows includes. The code that handles these things in Windows consumes resources even when the functionality is not being used. On Linux, the code simply is not there, so the resources are available for other purposes. The fourth is that Linux applications are often lighter than their Windows equivalents. Firefox on Linux uses less memory than Firefox on Windows. LibreOffice on Linux is lighter than Microsoft Office on Windows. The cumulative effect is a more efficient system. The fifth is that Linux updates are typically smaller and more targeted than Windows updates. Windows updates can involve gigabytes of changes and substantial system reconfiguration. Linux updates are typically small and specific, which means that the system does not accumulate the configuration debt that Windows systems accumulate over years of updates. The trade-offs of using Linux on older hardware include the following. The first is that some hardware, particularly Wi-Fi adapters and printers from certain manufacturers, may require specific drivers or configuration to work. The specific work required is usually modest, but it is real. The second is that some Windows-specific software may not have a direct Linux equivalent, and the user may need to adapt to using different applications. The third is that Linux requires a learning period during which the user adjusts to the different conventions. For users who are not willing to invest in these trade-offs, the alternatives are limited. Continuing to use Windows 10 without security updates is a serious security risk. Running Windows 11 on incompatible hardware, which is possible through specific workarounds, is unsupported and may stop working at any time. Buying new hardware to run Windows 11 is expensive and may not be financially feasible for all users. For users who are willing to invest in the Linux transition, the specific reward is that the computer they already own can continue to function effectively, with better performance than it had on Windows for years to come. The specific environmental benefit of not adding a functional computer to the waste stream is also worth noting. The broader observation is that the Windows 11 hardware requirements have created a specific problem for a large category of users, and the Linux response to that problem has been a specific opportunity for the Linux ecosystem. Users who would not otherwise have considered Linux are considering it because Windows has given them no other reasonable option. The specific distributions that serve these users, including Mint, Xubuntu, MX Linux, and others, are receiving increased attention and adoption. The specific market dynamic is that Microsoft's hardware requirements, which were presumably intended to push users to buy new hardware, have instead pushed a substantial number of users to Linux. The specific number is difficult to measure precisely, but the pattern is visible in user counts, in download statistics, and in the growth of Linux communities focused on migration. For the Linux ecosystem, this is a specific opportunity to demonstrate that Linux is a serious option for mainstream users, including users who are not particularly technical. The specific experience that these migrating users have will shape their view of Linux for years afterward, and the broader reputation of Linux will be affected by the cumulative experience of these migrations. Subscribe for the next video, which provides a specific walkthrough of installing Linux Mint XFCE on a typical computer from the 2010 to 2015 generation, with the specific steps, the specific configuration after installation, and the specific testing that confirms the installation is working properly. And in the comments, tell me what specific hardware you are running and what your experience has been with various operating systems on it. The aggregate picture of what works on what hardware is valuable for users who are considering similar migrations.